It was going on, guys, coming again here. So we continue our work on Deobfuscating, the world's smallest chess program written in JavaScript by Oscar Toledo. And in this video, we're going to be revealing the variables responsible for the move generation part. And before we start, I just want to give you an idea how the output looks like from the previous perspective. So currently it's not playing chess, it's a little bit disabled. However, if we call the search for one or another site to move, then here you can see like it's just generating the moves and printing them to screen, which is really awesome. And this is really helpful in terms of, let's just make it for another site. And it's really helpful, and it's going to be moving white pieces. It's helpful to reveal what kind of variables are we dealing with to give those variables meaningful names. But again, like every time I'm changing the variable names, I need to restore the entire app to the state where it can actually play the full-blown game of chess. So I just want to comment out my debugging code from here, and I want to restore the code, the original code for this recursive routine calls, and this one as well. We'll disable this later on, but for now, when it comes to digging even deeper, but for now I just really want to make sure that it's still playing chess and this is okay, so we can still go and play. Okay, great. So the very first thing to consider, so we said so here we make move and here we take the move back. So let me just, how I know this, because we've just been printing the board after this happens, and just from my general just programming experience perspective, I just know this, that we need to set the piece, the source piece onto the target square. We need to reset the source square, and then we take the move back. We need to restore the captured piece on this on the target square. And put the piece. Oh my god. Okay. Okay, let's just give some commentary. So here we want to make the move. I've just realized that it might be a little bit more sophisticated than I thought initially. And here we want to take the move back. So yeah, every single statement I'm making, we're going to be checking that out. So well, let's say here instead of n, we're gonna be placing, I'm not sure which one in particular, so let's consider like, I don't know, 13 white rook. Let's just make a constant here, and now no matter what side makes the move, well, okay, I shouldn't be disabling my stuff for this. Well, let me just very quickly disable here and just print the board. So now it should be so now on the target square there should be white rook every time. Okay, so we got a white rook here. Okay, which means, so see, like just a constant now, which gives us an idea that this is the source piece, so whatever piece we're moving. So this n should be treated as the source piece, and I'm just gonna state this. Well, this is very logical to call this a source piece. So let's search for all the instances of n, and oh my god, yeah, this takes ages to complete, but so yeah, starting from here, so next, and we want to replace this with a source piece. Okay, it might not always be the source piece because the code is obfuscated so much this is a real masterpiece, to be honest. So it might happen in future that before this n takes the value of the source piece, somewhere before in the code, it might be serving potentially some other purposes. And well, because it's just I can't say for sure because really lots of things to reveal here, but we just need to give some meaningful names for variables to, so when we encounter those later on within the code, it would be easier to figure out how else this variable is used within the source code. And well, probably we can just alter the names better in the future, but for now let's just assume that the n is the source piece, just because if we give it a fixed constant value, it would be like the piece that we're currently moving within our move generation process. So source piece, and this should be the very first definition. So here I just made a debugging code, nothing special. So let's replace, I don't want, so I want only the lowercase ones. Okay, next replace, okay, here replace, here replace, next, and this is pretty it, I believe. Okay, so now let's try to make it plain chess again, and hopefully this still should be plain chess. Okay, so no errors, which is great. No errors, right? Okay, so this is good. Now, so we are putting the source piece, but remember we've been putting this to whatever square that we place the piece to. So this T should stand for a target square. So, and by the way, it should be treated as the board array, even though it contains not only the data in regards to the board itself, but some additional things, even including the piece move offsets. But I was wondering that as far as I found the piece move offsets being stored in this L array, and it feels like they have been depicted from there to get the particular move offsets for a current given piece type. I think that might be this is just the matter. This happens just because of this obfuscated way to initialize all the data. So maybe just a redundancy there. It just gets initialized what it shouldn't be, just for the favor of the small size of code. This is just my assumption. I know this entire live stream video series is all about my assumptions, but yeah, we just go and we are checking out those all the time. So we also may replace I with a board, but that would be the next step. So first, let's search for our T. So what? Oh, no. Control F, Control H. Yeah, so I'm looking for T. Next. So where the T? Yeah, here the T starts. Okay, next. And so I assume that this should be a target square. Target square. Okay. So let's go for it. So replace. And next. Okay, sorry, just concede. Okay, next one here. Okay, next one. Okay, here we want to replace. Next. So here we want to replace. Previous, replace here, next, oops, previous, yeah, here, replace target square, replace, next, replace, 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 next. And if I did everything properly, let's save and let's have a look if it's still capable of playing chess. Okay, yeah, so just a bit weird random sequence, but yeah, okay, so it seems to be like still working and still no errors. So now let's have a look what we got. So board indexed by the target square is equal to source space, which makes perfect sense. And then when we take the move back, then board indexed by the target square, we want to restore whatever piece was there before. So this R should stay for a target piece. Okay. Yeah, so this might not always be, well, we could have checked that. And I'm wondering, so to the, okay, so let's better first deal with this O. So I assume this should be a source square. So because we reset that and we see this is exactly what's happening when we just push a piece. So when we generate the moves like pawn, knights, all this stuff. So we see like it's moved from the initial square, so it disappears there. So that's, it happens here. So I think that O stands, excuse me, so O, Control H, this should stand for source square. So one of the most essential variables, by the way. So O, and where the O is being, now target square is initialized to source square initial. This makes perfect sense. And yeah, and initially target square is equal to 20, and yeah, the next one would be 21, which is the very first index, assuming the 10 by 12 board representation. So probably makes like O plus plus or plus plus O somewhere, I believe. So yeah, so we started not from the 0, but from the index, where the next one would be the very first square. In our case, this is gonna be this one, H8. So H8 is the index of 21. So just to prove you that, just can have a look. Here it is, 21. Okay, so yeah, is this really defined here? First place. Okay, so O replace with the source square. Source square and replace. Oh, sorry. Control Z. Hold on a sec. Next. Replace. Okay, source square is equal to 20. Yeah, what I've been talking to you guys. So there should be the increment somewhere, and this is exactly the place where the increment takes place. So it starts from 21 actually. So yeah, yeah, my assumption was correct. Okay, so plus O. Is this gonna replace like? Oops, sorry. Oh my god, guys, I just probably, I'm sorry, I just forgot to initialize to. I've pressed Control R to update the screen. I'm sorry for this, and that just stopped my camera recording. So I have no idea where exactly it dropped. So yeah, let me quickly check that out, and then I'll say again what I've changed. Oh yeah, I'm sorry. So it just skipped probably another 10 or 15 minutes, but we didn't lose much, guys. So here are the variables that I have changed eventually. So keep still recording, right? So the target square, the source square, and source piece moved piece and captured piece. So just a few words on what are these. So the source piece is whatever piece we are moving during the move generation. Okay, so then the board indexed by the source square becomes 0. Okay, and now it's interesting when it comes to taking the piece back. So it's pretty clear that on the target square we should resume the captured piece, so whatever piece has been captured. Okay, but here the moved piece, why not to use the source piece here? Well, that's because of the pawn promotion. So in case I've been demonstrating this, but unfortunately didn't get recorded, so let me show you this one more time. Sorry. So let's just get away from this for a while, and here I just say console.log and let's say moved piece and plus, let's make it like a variable name, plus moved piece, and then plus then the captured piece and the captured piece. So I've replaced them everywhere within the code. Yeah, there was nothing pretty interesting there. Just replace all the instances by captured piece, moved piece, like this. And now we'll see how it works. So let's start a new game. And now here I want to place a white pawn. So this is how we can go for it. So we have a white pawn here, and now let's go generating some moves. Okay, so we capture it, promotes to queen automatically, and then we drop back. We have the moved piece equal to 9, which is the code of a white pawn, and the captured piece is 5, which is the black rook. But just to make it more clear, let's say pieces indexed by the moved piece, yeah, and pieces indexed by the captured piece. Yeah, I'm sorry. Yeah, maybe it would be too boring to watch all of that stuff, but yeah, I've been demonstrating this, but unfortunately, as I said, the video wasn't recorded really. So set up the pawn, and let's go. So here we go. So the moved piece is actually the pawn. However, and the captured piece here is the rook, right? And now what happens if instead of using the moved piece, we would use actually the source piece? So let's not print anything any longer here because it's enough to see it visually. So instead of moved piece, we just use the source piece. It seems logical. However, it's not the case. So I'll now show you why, guys. So, well, if we go for non-promotion, it works fine because it just restores the source piece. So this works like a charm. However, if it comes to the pawn promotion, let's print the board. Okay, even like this. So we just captured the rook, but when we drop back, we just retreat with the queen, which is horribly wrong because here should be a pawn. So it's a difference. It's a huge difference as opposed to how the promotions are handled in Micromax by Harm-Gerd Müller. So Harm-Gerd Müller, actually, after making a move, he just bitwise ORs the piece type with a queen, right, to get the promotion. So it's actually the promotion is done after the move is made, and if we just take the piece back, and nothing happens, just retrieves back with the pawn, because that is stored as the source piece. So the source piece would be the pawn all of the time in his case. But Oscar Toledo goes for a different way. I have no idea in particular at the moment how exactly this is happening. But this moved piece variable is equal to the source piece every time when it's not a pawn promotion. However, if it is a pawn promotion, in that case, it's just it turns from queen back to pawn. So here is how we can see this. So again, like this position. So we capture and then we go back. It just it turned back to pawn instead of being the queen. So in this case, moved piece variable is not equal to the source piece. So the moved piece would be either the source piece or the pawn, either black or white, depending on whether probably stands on 7th or 2nd rank. We're going to be revealing this later on as well. So I hope this is clear because this is absolutely essential. And now, now let's make it playing chess back, and probably we'll probably drop this video at this point because we've already revealed quite pretty few of very essential variables to work with. Save, and so just want to make sure it's still capable of playing chess, and it is. Okay, yeah, I just want to play e5. Okay, so here we go. Okay, great. So here we go. All right. Yeah. So we have the target. So yeah, the essence of making the move. So we want to put the source piece. Onto the target square. Board indexed by the target square, and board indexed by the source square should be resetted. So equals to 0. When we take the move back, we take this moved piece, has been explained, back to the source square, and the target square becomes equal to whatever piece has been captured, if any, by the make move. So I hope it's clear. And now probably the very last thing to consider is to rename this I to board. And again, like, even though the I itself, so we have a look at the I. So by the way, this print board function takes the first 120 elements of the I array to print the board, to translate this kind of like of board piece codes from here and so on to the Unicode characters to bring this to the board. However, it still contains some values that looks like to be the piece move offsets, like for rook here, or for pawn right over in here. So this might be the pawn. So like white pawn goes forwards, black pawn goes forwards, or like this case this is downwards. So if we have, do we have the h8 even equal to 0? No, it's equal to 21. But yeah, so yeah, but the ending is still the same. Yeah, so in order to make the white pawn moving forwards, we need to subtract 10. Yeah, because we have 10 elements with, and in order to move black one square ahead, we need to add 10. Okay, so and yeah, but despite the fact that the board array still has values that look like the piece move offsets, however, we can see also this has been stored in this L array, and again, like but apart from just the piece or the offsets which are available here, it has some specific additional values which I'm not sure what they do at the moment, and also it has the pieces themselves. Probably is used for mapping the piece type, like the certain piece code, to a specific index to get an offset for that piece. That's just my assumption. I'm going to be revealing that probably in the next video. But anyway, I think that it's fairly good enough for now to call, well, I'm not going to be calling this L array because I need to research it a little bit more, but I can already call the I array to, I can claim the I array to be the board, because the major data set it contains is the board array. So this I, it should be treated as the board. And now let's replace this within the source code, and this would be the very last thing we're going to be doing in this live stream in particular. So let's search for I, and apparently like this should be just okay, right? It's not that many. All right. So by the way, can I just go for replace all in one run? I just tried this, so let's call it board. Yeah, and I hold my breath and trying to replace all, and let's have a look if this is still capable of playing chess. It's not 157. Here, obviously, board. Okay. Excuse me. Save. Is it somewhere else? Oh, yeah, here. Here, board. '85. Oh, okay, yeah, in my own implementation as well. Board. Oh my god, what? Oh man, what have I done? Oh. I did something horribly wrong to Unicode characters. Okay, drop back. Okay, just drop back. Yeah, that was fun. That was really fun. Okay, let's actually go for, let's make it search like this and actually go one by one. Yeah. this was so fun. Okay, so yeah. Okay, so here, replace, next, replace, next, okay, replace, and replace, next. Oh my god, guys, I hope this disaster is not gonna happen again. Okay, yeah, thank god. That was fun. That was really fun. Okay, I think this is really kind of good, good enough time to end with this series. Yeah, so just to wait to what it lasted forever. Okay, so just a very brief look at the source, the deobfuscated source code we have so far, and now it looks like much better, I believe. So we have the most essential things like the board array being revealed, target square, source piece, captured piece, the moved piece. Okay, so captured piece seems to be self-explanatory, but let's just clarify. So whatever piece that was occupying, oh my god, did I write? I don't remember how to spell it properly, sorry. That was let's say land in the target square before move was made. Okay, So whatever piece that was landing on the target square, let's just, sorry guys, just want this occupying, is this proper? Okay, so whatever piece occupying the target square before a move was made. Great. And yeah, this is kind of it. Save, and let's make sure that we have a playable game still. Yeah, so it's not that bad at all. And hopefully in the next stream we're gonna be revealing how exactly the target square is being kind of like generated. So I guess this happens somewhere here, and we have this. So C seems to be the constant, just pointing to the current move offset that we need for a certain piece type, and we're searching for that within the L array. So this gives me an idea that we can call this L array to be like the move offsets, even though it contains some additional information, not only the move offsets, but anyway, that seems to be only used for the purposes of just getting the proper index to get the move offset for a certain piece type that we're looking for. Okay guys, so this is it from my side. Yeah, thanks for watching. Let me know in the commentaries what do you think about this series. And I don't know how you guys, but for me personally, the deeper I dive into this masterpiece code by Oscar Toledo, the more excited I'm getting, because like, it's not like, if we have a look at Micromax by Harmgert Müller, it's pretty simple in terms of it's not being that obfuscated. Like, it's very transparent, it's clear what's going on there. But here the design and the implementation is a true masterpiece. So I just I don't know how many time it takes to reveal all the secrets, but what I've realized so far about the implementation, like what I can assume about the implementation, is really, really brilliant. So I hope you share this brilliancy as well, and I hope you're as excited as I am, because again, like, this is just a legendary code from the legendary developer, to say at least. Okay guys, so yeah, now this is really it from my side. So thanks for watching, until the next time, and take care.